Perfect. All right, good morning, everybody. So, oh, hey, there's Tyson. Hey, Tyson. And Victoria just joined us. Hi, Victoria. Yeah, so we got the full crew now. All right, so, today on this, so we have 2 hours today. I imagine that for the first hour, we're probably gonna go through and finish that intro to R and RStudio that we started last class. And then the second half of today's class, we're gonna start working on EO monitor data cleaning. I was finishing to put together the script yesterday, and I thought it was super cool just to compare the raw and clean versions of it. So I wanted to give you guys an idea of what we're headed towards, and we'll talk more about why that's important. It's a very important step in Precision Ag as well. Okay, so to resume where we stopped last class, I'm just showing you here. This is my folder. This is how I have it set up now. And also, I just want to give you some idea as well of perhaps what would be the best setup as far as folders and subfolders for you to have and be easier for you to follow as we move along. So I have this overall folder here for the class, which you probably already have one in your computer as well. And then I have in here the 2022 Advanced PA folder, which is the one that is linked to GitHub. So in my case, I personally edit this folder here. For you guys, you probably will not need to edit that as much. We're going to finish today editing that R script that is inside of this folder on the class code partial. But after that, I don't think you're going to have to really edit this folder anymore. It's just going to be a way for you to get the data and scripts that I send you. And what I imagine you doing, well, let me just stop here and I'll tell you more about this when we actually move into the EO editing part. So for the first part, you can just open the folder that you downloaded from GitHub, and you can go under class code and just double click that .r partial script that we started last class. And this should prompt you to launch RStudio. Okay, so this is what you should be seeing. So that's 0207 underscore partial on top. And then our script here, and then everything else that we saw already as far as having the console, the environment, and here are some tabs that we'll be using later. Okay, is everybody, I mean, if someone is not at this stage, please let me know and we'll just hold a second for everybody to catch up. Is loading? What was that, Sven? Okay, okay. Yeah, I'm just gonna wait a moment here. And while it is loading up on your laptops, I'm just gonna say some things here. We're not gonna be coding quite yet, so I'll wait for you to be ready for that. But just to kind of catch up here on what we did last time, right? So we talked about R and RStudio. Why is RStudio and R useful, and how RStudio helps us to integrate different parts, where R is one piece of it. So the console here is what R is, if you were to open only R, and then RStudio is everything around it that helps us to to combine different aspects all together in one screen. Then we talked about doing some math, creating some objects. We use the C function that means concatenate just when we want to create a vector and assign that to an object. We saw we can also assign entire words, in this case here, workshop. We created a data frame which has columns, right? So a data frame has distinct columns where, let me increase my font size here. Oh, and let me just turn off the light here so the guys in the room can see better. Okay, is that better? So we saw the concept of data frame, and then Sunam asked this really great question that, so a data frame has a very fixed structure as far as how many columns it has, how many rows it has, and it's always going to have that rectangular shape, right? And if you do have columns that have NAs in them, those columns will not have fewer rows. They're still going to have the same number of rows as the entire data frame. They're just perhaps going to have NAs in some cells to show that they don't have all the data that other columns may have. Then we saw what a matrix is, how we make one. And again, I don't anticipate you guys using matrices too much. Probably you're just going to be working with data frames for the most part. Then we created a list, and I also don't anticipate you using lists too much yet, but my hope is that I get you guys excited enough that you want to continue using R after this class. And so eventually we'll start using lists more as you get better and start doing more complicated things. We saw the use of the function class, which just helps us to understand how R is interpreting the type of either an entire object or parts of that object. So I can ask for a class for the entire list here, or I can just ask for the class of one element of that list. Or if you think of a data frame, I can ask for the class of the data frame and also for its each one of its columns by using the $sign to get inside of that data frame. You know, and also let's do this. Let me see, probably, because I'm just speaking here, but we're also going to have to run some of this code here just to make it work. So I'm just going up on my script. I just came up here to where we define B. If you can just run that part. So we're going to see on the console that it sends B. It doesn't have to print it. We just need to have it in our environment because we may use it for when we continue from when we stopped last time. So I just ran B just to have it in my environment. I can see there. And then we were talking about what is a function, what is an argument inside a function. And I think we stopped right here. And the reason why I introduced you to the arguments inside a function, I don't think we really went through the reasoning why I wanted to expose you to that. So let's just run here as well the object B2, which is basically the same as B, but with an extra NA. So if you can just run that, it should be appearing then on your console. And we already had this code in the script. And then we were just talking about how the function means. So a function is defined by a word that has been programmed to do something. And we know it is a function because it is followed by an opening and closing parentheses. And then inside functions, we have arguments. And these arguments are things that are either inputs to the function, like in this case here, B2 is the input, or is something that changes how that function behaves. So if you remember, na.rm stands for NA, which is not available, remove. And if we just run this, if you recall, the default behavior of the main function is for this to be false. So if we run this, we get an NA back. However, if we want to change that default behavior, we have to explicitly say it. So NA remove equals true, meaning now I want the main function to remove NAs before calculating the mean. In which case, if we run it, then we get the actual mean of the remaining numbers, right? So we remove the NA, and then it gives the mean of the remaining numbers. And the reason why I'm showing this is to make the main point here is the argument point. So if you remember, we use the function help mean to see what are the available. So if we just run this, it's going to pop up here on the side. And we were exploring here what are the arguments. So here has a heading called arguments, and what are the arguments and the sequence of those arguments that this function takes. So here we see X is the object that you want the mean over, and then it has a trim and then NA remove. it has this order, right? So if you don't call out the name of the argument and you still want the function to work as it should, then you have to give the arguments in the order that they're listed here. So for example, if I simply said here mean of B2, and then I say true right away without calling NA remove, it's not going to work. And you can just run it to see for yourself. It's saying here that there was an error, that trim must be numeric. And the reason why is because if you don't call out explicitly the name of the argument, and also you don't provide that argument in the order that's specified in documentation. So here, X is the first one. So X is our object that we want the mean. But then the second one is trim. So it's looking at this true and trying to fit this into that trim, which should actually be a number and not true or false. So that's why it's given this error. However, when you do call out the name of the argument, then the order that you provide is irrelevant. So I could even do like mean, and then I could say NA remove equals true, then X equals B2, and this should work. Yeah, so it works perfectly. Even though it makes sense that the first argument that you give it is the input, in this case B2, but if you call out the argument name, it doesn't matter the order. The order matters if you're not explicitly calling out the argument name. And this can be, and this sometimes can be, you know, it's not a huge deal, but it's something for you to be aware of. And if you want to know what order that function accepts, or what arguments it has and what order those are appearing, then you would use the function help, and then whatever function you're trying to get more understanding of, you just put that name there, and then it would learn that by seeing here on the arguments list the order that those arguments appear and what they do.
Leo, I have a question. Is NA the only way you can report missing data in R?
Yeah, for the most part, I would say yes. What happens sometimes is that there are a few different types of NAs. And for now, I don't think we really have to get into that conversation because it's a little more complex. But just quickly mentioning that, for example, if your column is a character column, let's say you have a column called site, and you have like Tifton, Athens, and Griffin, other names there. And for some reason, there is a site that I don't know. For some reason, you don't have the data for that. It would be, I mean, it would be NA, but the way the R sees it is NA character, which is different from if a column that's numeric has an NA, R sees as NA numeric. So yeah, it's still NA, but R sees differently behind the scenes. That detail can be important for more complex applications, but for what we're doing here, that shouldn't be the case.
So I'm getting a little bit probably ahead of you, but just because it's on my mind, you know, in Excel, typically we do different things to indicate missing data. Some people put in a dash, some people just leave a blank cell. But we would need, if we were bringing in a data set, you know, anything that we would consider missing, we would need to pre-code as NA, right?
Yeah, so the way that it works is if in your spreadsheet or CSV, if you have an empty cell, that is interpreted as an A when it comes into R. If you have another notation for an A's, like you said, maybe a point, a dash, some people use like 9999 or something like that, then you actually have to program that after you're reading the data set. So then you have to change those values.
But a blank cell is automatically assumed to be NA.
Yes.
Okay, very good, thank you.
Yeah. Okay. So so next thing here is, so we just finished talking about some of the syntax related to functions and arguments. And now I just want to clarify one point here. So if you come down, I just want to clarify this point of installing a package versus using the function library. So we use the install packages function. In this case here, you can actually go ahead and run this while I speak, because I want to install this package called Tibble that I have not asked you the first time. So if you can just run that line of code there, and we can allow it to do its magic while I speak here. So install packages is something that you basically do once when you're truly downloading that package and installing in your machine. You may use it again if you want to update the package. Let's say if you have a new version of the package, you want to have that functionality that has just been released, you would use it again only then. However, every time that you open an RStudio or R session and you want to use the functions inside a package, you have to load that package. The reason is, at this point, we probably installed, I don't know, 15 packages, give or take. But the more you do things, the more packages you're going to download and need. And I probably have over 200 packages that over time I installed. It does not make sense for R to give you all that functionality available in every session, because you're probably not going to use all those packages in any given project. So that's why we have to use the function library to load a package. So to load basically means it's already installed in your machine through the install.packages function. And now you're just making those functions available to you during that specific R session. So we always have to load a package that we want to use. So we just installed here the install.packages. I just want to ask you to run the library tibble. That should not give you any errors. We should be loaded. And this package tibble here just give us access to a function called tribble, which I don't want to get too much into detail. It's just an easy function for us to create data sets on the go. I do not expect you guys to be creating data sets on the go. You will probably have your data sets from outside and we'll be reading them into R. So the function tribble here is just to make it easier for us to create an internal data set, which you will not really use, but anyways. Okay, so what I want to do now is I want to ask for you guys' help here for us to develop this data set, this object that I'm calling intro. So you already have this piece of code. And the way that this function tribble works is you give, using the tilde, you give the names of the columns that you want to have. And then, you don't have to hit enter. I hit just to make it easier to see. So name would be Leo, height, here is in meters, but we can always change that if you don't know your height in meters. We can change to English units. But 1 meter and 80 centimeters, and pineapple column is whether or not you like pineapple on your pizza. So I'm gonna ask for a few of you, any volunteers, and if I don't get any, I'll just call out names. If you wanna help me just to fill a few rows of this data set here and build that with me. So we're gonna use this and explore this data set lower here. Any volunteers wanting to share this 3 pieces of information?
We can start with me.
Okay, perfect. So I know your name.
Yeah, and I used to be 180, but I've shrunk and now I'm 178.
Oh no.
And I do not like pizza, pineapple on my pizza.
You did not, so I'll just put a false there.
False, yes.
Like, so T is for true, F is for false. All right, anyone else?
I'll go.
Okay, Emily.
And I think it's 1.65 meters.
1.65 meters. Perfect.
And then I don't know, it just depends. It depends on what else is on the pizza. Let's go with false.
All right, false. Okay, one more person, one more volunteer. Maybe somebody here in the room. Victoria, is it okay? Okay, I'll just start typing here. Victoria, what is it in 5'7"? So that would probably be, I actually have no idea. Let's Google it. So 5'7".
162, I guess.
162.
I'm 5'5", so 165 is 5'5".
Okay, so we'll go with 162. Is that all right? And then, do you like pizza, or do you like pineapple on your pizza or not? You do. Awesome. So I'll put a true there. Okay, so we just built this internal data set here. If you go ahead and if your cursor can be really in any of these rows here, if you just run it, it should appear on your environment, and we can just go ahead just quickly and print it. So I'm just going to call intro and run that again so we can see what happened here. So we have the three columns that we asked, so a name, height, and pineapple. We see here that R is kind of telling us how R interpreted the type of these columns in this data set. So name is a character, which makes sense, right? Height is seen as double, which basically just means numerical. And then pineapple is seen as logical because it is true or false. Oops, sorry, I need to minimize all the way. Okay, so let's just quickly do some checks on this data set. And the functions that I'll be showing you here are actually very useful for any data set, including this fake one, or not fake, but this playful data set here. So let's use the function class and call our data set, our object name intro, just to check what it is. So if you run it, R tells you it is, so it has three names here basically, but the important thing to note is that it is a data frame, as we would expect. And it has some extra nomenclature here because, I mean, we don't have to get into that, but these are all different ways of referring to a data frame in R. But the main point is that it has data frame right there. Okay, so now let's use the function summary.
Leo, I have an error when I ran mine, and I'm not sure why.
Oh,
Could we go back to Tribble just a moment?
oh yeah, absolutely. So,
So the error I have, it says error in Tribble, could not find function Tribble.
okay. So did you, maybe if you try to run library Tibble?
I ran that, and
did?
I got that it was successfully installed.
Did I get this wrong? Let me ask for help Tribble. Maybe.
I think Professor, you're talking about the install Tibble. Dr. Bliss, you gotta do the library Tibble, so it imports the package into your R.
Again, I didn't understand what.
The one you're talking about that it got installed is the return for when you install the package, not when you call your package using library Tibble. So you write library Tibble, so your package gets like imported into your local directory. So first you write install packages Tibble, and then you write library Tibble.
Yeah.
Right.
Okay. So I have to run library Tribble as well.
Yeah.
Yes, library Tibble. Yes. Just make sure that, because the function is Tribble with an R,
Okay.
but the.
Let me share my screen so you guys can see what's going on, because it's giving me more errors, and may not be the only one that's got this problem.
Yeah. I think I have to stop, right?
Yeah, stop sharing for just a second, and then let's see if I can share.
Were you guys able to run?
Mine also had the error.
Also had the error? Was it the same error saying, okay. So when you ran the install, well, let's see here. Let's go through George's screen and then we can see.
Yeah, you're able to see my screen?
Yes.
Okay.
Okay,
So
so.
I have run this. I've run this, and I run that, and so here it was
Now
when
it
I
should
ran.
work, I think. Yeah, now it should work, Professor.
Well,
Yeah.
when I did run Tribble, it could not find function. So
Yeah,
it should
now
work now.
you oh yeah, it should work now. Yeah.
Okay.
Yeah, so if you, yeah, let's see.
All right. So let's run here.
Yeah, so now it
okay.
worked. Yeah, I think it's exactly what Sunab was saying, that is just that distinction between the installing and the library for loading the package. I think perhaps in your case you did install, but maybe you didn't load it using the library function.
That's exactly right. Yes.
Yeah.
All right. Thank you.
Yeah, absolutely. Victoria, is that what did I help in your case? Okay, I think I'm gonna go ahead and start sharing mine again while we.
Okay, so if anybody runs into problems like I did, please stop us and make sure that we can solve your problem, right? Because it's very easy to miss a command like I did.
Absolutely. And especially here, like in George's case, it was the function that was not available because the package wasn't loaded. But sometimes it could have been like a missing comma, which in this case here is very easy to miss because there are many of them. So, yeah.
Dr. Vassos, I have a question real quick. So whenever the output, it's got our column names and then what we input, and then below the column names, it has like the type. So character double, is that what that is underneath there?
That's what it is.
And do we set that in any way, or the package just does that?
So we set indirectly, basically. So here it knows that name is a character because we're including everything with quotation marks.
Mhm.
So let's say, I just want to do very quickly here. You don't have to do what I'm going to do here next. But if we were, so because we did not use quotation marks on the numbers, R sees them as numbers. But if we were to do this, let me just do one and see. Yeah, so it didn't even like what I did here because it's saying, well, in this column height, you have one character and then 3 numbers. That doesn't work. They should all have the same type. But if I just go ahead and put all the numbers with quotation marks and run it, then R will see height as a character as well.
Okay.
And that's not
And
what
then
we want. Sorry,
And
go
then
ahead.
it just assumes, or it knows that T and F is always going to stand for true and false.
Exactly. Mhm.
Okay.
That's what it did.
Okay.
Yeah, and
good deal.
this
Thank you.
system here, it's really, really important, not right now, but like, let's say if you're running, I ran into this many times and it's so easy to just overlook this. But if you're running, let's say, if you're in grad school, and even if you're in undergrad, but you're running experimental analysis and you have like a randomized complete block design, for example, the way that normally we code our blocks, at least the way I do, is with numbers. So I call 1, 2, 3, 4, right? And then you bring that into R. R sees blocks as a number, as numerical, and then you're going to run your ANOVA, and you see there's like 1 degree of freedom, but you had 4 blocks. So clearly it's wrong. And what's going on there is because R saw that block column as numeric, it's actually trying to fit an intercept and a slope instead of looking at each one of them as its own categorical variable. So this is one of the reasons why knowing how R is treating your variables is really important, especially when you get into analysis. And I don't think we're going to get into that part of it into this course, but I have some workshops that I taught with that, and they're freely available if you guys want to see later. But it's just like one of the reasons why knowing about the function class, understanding the different classes, and knowing how R is treating your variables, and if that is the right treatment or not. In that case, I had to transform, after reading the data into R, you have to tell R, look, this column here, block, is actually character. It should not be numerical. And then you're going to have 3 degrees of freedom on your ANOVA when you run, if you have 4 blocks. If that makes sense. If that doesn't make sense, then don't worry about it. But yeah.
Thank
Okay.
you.
Yeah. So Victoria, were you able to run?
Yeah, it just says creating a data set is stored in the console. Should it have like the actual data set?
So do you see the greater than symbol in your console?
Yes.
Yeah, so then it means that the console is in idle, which means it has already done what you asked it. So probably has already created this object. If you just type intro and run it, it should print below here.
Okay.
Yeah, perfect. All right. Okay. If anyone has had any other issue, please let us know right now before we move on.
Please clarify again what intro does.
I mean, intro is just the name of the object, right? It could have been anything else. It's just because it's for introductions. Sorry, I didn't hear what you said.
We're just running intro, which is what we did with when we call it tribble, right? So the intro is just a variable, for example.
Yes, intro is the object which contains whatever we define on the right side of the assign symbol. So here we're basically creating this data set and saving that into an object called intro. Yeah.
Thank you.
Yeah, absolutely. So if we run this, so we check the class, it is a data frame. If we run the summary function, what the summary function does is it looks at each of the columns Oh, I actually have to rerun my intro after I removed you don't have to do this, but I added the quotation marks. So I just have, and then I remove them. Yeah, there we go, double. So if you run summary on your intro, oops. Let me go again. So what summary does is it looks at each one of your variables, and depending on the type of the variable that column is going to give you a different type of information. So it looks at name, it notice it is a character variable, and it basically just gives you the length. It's basically how many values you have in that column, which is 4, and we know that. And then next it goes to height. It realizes the height is numerical. So here it gives you a brief statistical summary with minimum, first quintile, median, mean, third quintile, and max. And this is by default because it sees that this variable is numerical and gives you that by default. And then pineapple here, it sees that it is a logical type of variable. And so it just gives you the count, how many falses, how many truths. This function summary is one that I use a lot, even for very complicated things, and it's always helpful. And you're going to see when we started working with EO data, how this can be helpful to catch mistakes on your data before you do anything with it. Okay, I had, yeah, so there are a couple more functions I want to show you here. For this data set, it's not super important because it is a small data set, but there is a function called head. So head intro, that if you run it, it's going to give you, I think, the first 5 entries of a data set. In our case, our data only has 5 anyways. So let's just give, so it has this argument called n for how many entries you want to see. Let's just say n equals 2, just so it's more meaningful in our case. So it only gives the first 2 rows. This is really helpful. Let's say if you have a very large data set, right? We're going to see our EO data set has like 30,000 rows. You don't want to print 30,000 rows on your console. So the head function helps you to just get a glimpse of what is in your data set just by showing the first few rows of that data set. Similarly, there is a function called tail, and we can just say intro again, and let's just say n equals 2. It's the same idea, except that now instead of looking at the first 2 rows, we're looking at the last 2 rows. And again, here is a very small data set. It's not that important, but if you have a large data set, this can help you to just get a glimpse of what's going on. Okay, so now I want to show you guys some ways of sampling or perhaps subsetting this simple data set. Okay, so let's say if I only wanted the first row of this data set. So I'm just going to write intro and run it so we can see. So let's say for some reason I just want to extract all the information for Leo. The notation that we use in R is you type the object name, in this case a data set, you open and close brackets, and then here there are 2 positions. So there is the first position and then a comma and the second position. The first position in R, and if you remember the matrices, that the way that matrices names were appearing when we printed, it also used the same idea that the first value here is referring to the row position, the second value is referring to the column position. So if I want all the information from the first row here, what I would do is just type 1 on that first position and leave the column blank because I want all of them. So if we run this, it should return only the first row, all columns. Okay. Similarly, let's go to the next one here. If I want instead the first column only, so I just want, let me just type intro and print so we can see again, we have 4 names. Let's say I just wanted the information on the names. And we use this notation here as well. We would leave the first space blank and we'll use 1. So remember, row position is the first, column position is the second. So if we do this, we only get that first column. Okay, these are pretty simple ways of subsetting this data set. Let's add a little bit of complexity here. So let's say that instead of just one row and one column, let's say I want more than one row and one column. In this case here, so I just type intro again. Let's just see what it is again. Let's say I want rows 1, 2, 3. So 1, 2, and 3. We do that by using the notation 1, colon 3. So 1 colon, if you just run 1 colon 3 here on the console, it's gonna basically expand into 1, 2, 3. In this case, again, is not a huge deal. It's just 3 numbers. Well, let's say if you wanted a sequence from 1 to 20, that's what it would do. It would expand into. So if we want rows 1, 2, 3, and also columns 1, 2, 3, this is how we would call it. If we run it, you see that we did get the rows 1, 2, and 3, and we did get columns 1, 2, 3. We only had 3 columns anyways. So again, this is a very simplistic data set that these functions here don't seem to really be doing a whole lot of work, but they would work for more complex data sets as well. Okay, so lastly here in our subsetting example, I want to add yet another little bit of complexity here. So let's say if instead of going 1, 2, 3, meaning 1, 2, and 3, if I only wanted rows 1 and 3, so not 2, only rows 1 and 3, and columns 1 and 3. So in this case here, the main difference from the previous example is we do not need row 2 and column 2. How do we do that? If you thought of the function C, you thought it right. So because we want 2 rows that are not consecutive, so 1 and 3, we will have to use the C function, and inside of it say 1, 3. And remember, this here is on the row position. We have this comma here, and then we have the column position. So if we want columns 1 and 3, we would also use the C function and say 1, 3. If we run this, we see now that, so Leo was first position, Emily was third, and then columns name was first and pineapple was third. So we see here how we can combine those different things to subset a data set. And I just want to give you a very quick disclaimer here. This could be thought of as data wrangling. And if you've never heard of this term before, it's just a way that people use to describe when you're doing manipulations in a data set, and not in a bad way, not like manipulating data to be a result, not that type of manipulation. Manipulation in the sense of changing columns to rows and subsetting, filtering, those type of manipulations. So this could be considered data wrangling. However, this is not how data wrangling, this is not how I do data wrangling. Some people do data wrangling art this way. I think it's perhaps getting a little bit outdated to use this way. And I do not anticipate you using this way too much. However, because it is the traditional way and the basic way that R started, I still wanted you to understand this before we actually go and on the yield exercise, actually use the functions that are going to be modern data wrangling, if you will.
Professor, can I add something, please?
Yes, absolutely.
Just like you said in the second part, when we only need the first and the second, the first and the third column, can we say like we do not need the second column and we just write intro -2, -2?
Yes, that's a really great point. And I have not done this using this type of data wrangling before, but I think this is how it would be. Let me try. No, it did not work. Maybe minus.
I actually use, yeah, -2 is what.
Yeah, so minus. Yeah, you're right. And that's a really great point. And here in our case, it's not, I'm just going to change it back to what it was because I don't want you guys to be confused. That's a really great point because sometimes it is easier to specify what you do not want than what you want, right? Let's say you have a data set that has like 100 columns and you actually just do not want like 3 of them. So you want to exclude 3 columns. It's easier to say remove 1, 2, 3 than saying keep 4 through 100, right? So that's definitely a really, really great point just to think about that. Yeah. Thanks, Anab.
So the interesting thing about R and other programming languages is the way I manage these things, that you have to start thinking of the programming language as a person and trying to get into that person's mind. Okay, how does this person or the program need me to express myself so I can get back what I need, right? So it's almost like you're interacting with another human, and you've got to find the proper communication language. That's more or less the way I view it. And you have to get into the head of the person who's R now.
That is very true. And let me tell you that, like, so I've been programming in R for, I don't know, 6 years or so. And the more complex things I started learning in R, I actually started changing the way I think about things outside R in an R way. It's kind of weird, you know, it's like, you know, what, so you're going to see more when we get to the yield data that we're going to do data wrangling steps. Like, oh, first I do this, and then I do that, and then that, and that, you know, in a sequence that makes sense. And before R, I guess my head knew what to do, but not exactly the right sequence or the best, not the right, but the best sequence. And then you start thinking about, like, how would you do this in R? And then you're, yeah, sorry, I derailed a little, but just to say that I completely agree with that. Okay, so now let's get into doing some plotting here. I want you to load this package, gt.2. You have already installed it the first time that I sent you. So if you just go ahead and run that, you're going to see it on your console. And I want to print here our data set, just so we can take a look at it. And here I want to ask for help as well. If we were to make a plot with the variables that we have here, okay, what would you place on the x-axis? What would go on x? What? And there is no wrong or right answer. You can just tell me whatever you're thinking.
Height.
Can you say that again?
Height, or I would put height on the x-axis.
On the x, okay. So let's just, I'm just gonna write here just so I remember what you guys are saying. Okay, so if height goes on x, what would you place on y, given what we have here? Would anyone else like to shout out something?
You want to explore the association between height and whether we like pineapple on the pizza or not?
That could be, we could do that. Yeah, let me do that. So let's do, so on y, let's put pineapple. So if we were all in a class here, I would just draw this so it makes more sense. But right now, before we do anything, just try to imagine that we're doing a plot where x is height and y is pineapple, okay? So we're going to use this package called gt.2, which is a very, very modern way of programming graphics in R. And there are different ways of doing graphics in R. There are basically 3 ways. One is the basic type that I'm not going to be exposing you to. And then, I mean, the 2 main are basic and ggplot2. ggplot2 is what I'm going to be showing you because it's what I use and what I think is the most intuitive and flexible. So, and I'm saying this just so you are aware, because if someday you are like, how to do a box plot in R, if you ask Google that question, you'll probably get answers that will help you to make a box plot using base R and ggplot2. What I normally do for plotting, if I'm trying to look for help on Google on how to do a plot in R, I usually say how to do a box plot using ggplot2 or with ggplot2. And that's what's going to give me the answer that I'm looking for. Just in the distinction, again, is just so you're aware of a little bit of the history and what has happened with our development and where we are now. Okay, so let's, you can just come right below the library function there. And the way that every ggplot or every plot with ggplot starts is with the function ggplot. So you can just type that, open, close quotation marks. And the first art, so if you hit tab here, you're going to see that it gives you a few arguments. The first one is going to be the data. So in our case, data equals intro. You want to add a comma after intro. And then ggplot has this. So the second argument that we want to fill is what ggplot calls mapping. And here is where we're going to say what goes on X, what goes on Y. And the way that we do this with ggplot is we actually call another function that is called AES. So if you can just add that to your code, what AES stands for is for aesthetics, is for how a plot looks. And it's gonna make a little bit more sense just in a second here. But here inside the AES is where we say X equals height. And then you add a comma. I'm going to hit tab just to break line and not make this as long on your screen, but we didn't have to break line for the code of the sake, for the sake of the code. And so X equals height, comma, and then Y equals pineapple. Okay. So if you all have that, and if you run it, oops, I misspelled pineapple. So it has to be exactly the way you spelled in that. Yeah, so I'm missing another P there. And this is also a good reminder to tell you. So R is case sensitive. So if you save as intro all lowercase, and I tried to print intro with I uppercase, R is not going to know what I'm talking about. It's going to say object intro with I uppercase does not exist. So just so you're aware, R is case sensitive. Okay, so if we just run this piece of code here, as we talked earlier, when you're using R scripts, which is what we're using now, your plots appear on this screen right there. Okay, so this is how our plot looks like. If you see, R did exactly what we asked it to do. It placed height on the X. It looked at the range of values that that column had and already restricted the range of the plot to the range of values. And did the same with pineapple. Saw the pineapple was true and false. Okay, so however, R or ggplot in this case did not add anything else to the plot. I mean, the plot inside of it is empty, right? So we set the X and Y, the axis ranges, all that perfectly, but there's nothing showing up in the plot. The reason for that is because we did not ask it to add anything else to the plot. What do I mean by that? In this case here, perhaps is not as clear, but let's say there are multiple different ways that you can show data, right? It can be a point, it can be a line, it can be a pie chart, it can be like a trend line, it could be a regret, it could be so many different ways. And we just did not tell R what to do, and it didn't want to assume. So in this case here, how do you guys think it would be the most the way that makes the most sense to show this data? If you were just thinking about the main forms like point, line, pie chart, others. Any thoughts?
I think bars.
Bars? That's a good idea. Let's do that. So to add a bar here, what we do is at the end of the last parentheses there, we add a plus and we hit tab just to break line. Again, it's not needed. It's not like the code is going to break if you don't hit tab. It's just to make it easier for us to see. And then the way that we add bar, or if it could have been also a point perhaps, is what in ggplot language is called a geom. So geom stands for geometry. So we're just telling it what geometry we wanted to use to represent this data. So we do that by doing geom underscore, and then it just gives you here the auto completion gives you a whole bunch of options. We're not going to go through them, what they do, what they don't, but just so you're aware of how many ways that you can show data using ggplot. So let's do, I think what we want here is geom I think it's geom bar. Let's try that because there are a few different options to show bars. Let's just try to run that and see. Let me try geom call for columns. I know perhaps that one would work as we intended. Yes, geom call did what we wanted. So we would like to use geom_call for columns. Okay, so however, there was something here that happened. It's just that the way that geom calls work. Let me just try to do something here. You don't have to do this. I'm just trying to understand. Or no, it wasn't that. So geom call, just the way that it works, and I think perhaps it's because we have the bars going horizontally. It's just not working as I wish. And for sake of time and not having to troubleshoot it right now, let's just change it to point. But again, you can do columns. And I can send you the code that works best with that, just so I get all the bugs out and don't spend time right now. But let's do geom point just to see what happens. Okay, so I changed geom call to geom point, and look what happened now. So it's doing this plot where for each one of us that had data in this data frame, we had a height and whether or not we liked pineapple in our pizza. So it just placed a point where those two layers intersect. Okay, so now we asked explicitly how ggplot should represent this data, which is using geom point. And let's say I actually want to change the color. I wish we could do perhaps a red. So to do that, we would come here on geom point. It has an argument for color. I'm going to say equals, and then you have to open and close quotation marks and type red. If we run that, all of our points are now red. Now let's say I actually don't like the point shape. I would like a different shape. We can also change that. So if you come here after red, you add a comma and you type shape. So the shape argument is actually numerical. It has a list of like 30 different shapes that they go like 1 through 30 or so. And the default one is the shape for the circle that we're seeing is 1. So let's just do shape equals 2 and see what happens. Okay, so 2 is a triangle. Okay, but now, what if I tell you the following? Let me just print again our intro here, just so we can see again what we have, what we're working with. So to me, and especially when I'm doing very complex plots, I like to show the most information possible that needs to be shown. And in this case here, we're showing two pieces of information. We're showing height and pineapple. What if I wanted to include in this plot the names? Like I wanted to be able to differentiate which point is which one of us on this data set. How could we do that? Do you have any suggestions to add this third layer of information, which is name? Say that again.
Would it take a Z since we've got X and Y? Could they make it?
We could do that. I normally don't do that as much just because like 3D plots are very useful if you can interact with them, right? But like, let's say for a paper, they're a little bit more limiting just because you don't have that interactivity. But that is definitely something we could do. But there are other ways, I guess, we can go. Yes.
Can we put a legend name on each point as what points they are?
Okay, we can do that. But how would that change in the plot? You know, like, because a legend has to have different levels, right? So let me, yes,
If
go.
we put the second y-axis on the right side,
So I think that could be done, but I don't think it's, because it would kind of like, because let's say if we have another axis where we have like name on it, another y-axis, I think you would kind of fight with the pineapple one because they're not gonna fully match. So let me tell you what I'm thinking. What if we could give different colors to different names? Or perhaps different shapes to different names? Why don't we try that? To do that, so right now, if you notice, we changed the color to red and the shape to triangle for all the points, regardless of any other external variable. What if we wanted to actually assign different colors and also different shapes based on a variable, in this case, name? So I want to invite you to just like copy this geom point. You can just add a comment there to kind of like hashtag it out, comment out, so R doesn't try to interpret it, and just paste what you just copied, because we're going to change this code, and I want you to have both versions so you can compare if you want. So whenever you're trying to map some aesthetics like color, shape, size, fill, transparency, when you're trying to assign an aesthetics like that to a variable, it has to be inside the AES function, the aesthetics function. And that aesthetics function is actually, you can change it at a ggplot call level, so at the top level, or inside of the geometry level. Let's do inside of the geometry level. So come here inside of geom point to do AES, open and close quotation marks, and let's say color equals name. And let's run that. So Nab, is that kind of what you were thinking?
Yeah, kind of, yeah.
Yeah, so now we see that each one of us can be identified by a color, and the legend is on the right. And R has already selected the colors, the default colors for us. Now, what if I wanted to change the shape instead of the color? We would say here, instead of color, we would say shape equals name. We run it. So now we see that it's changing, it's given a different shape to each one of us, and the legend here shows which shape is assigned to what name. Cool, right? So what if we wanted to change both shape and color? So we basically just come here right after the shape equals name, add a comma, and just say color equals name. If we run it, now you can see that not only the color, but also the shape is changing for each level of the column name. So this is kind of, this is a very simple and quick introduction to ggplots. And what I really wanted you guys to take out of it is that ggplot works on layers. So first, that first ggplot call is where you define, most importantly, your X and Y axis. We could, if we wanted, we could also include shape equals name and color equals name up here on this aesthetics function up, and not do that here. In our case, it would not make a difference because we only have one geometry that we're using, that's geom point. However, if you do specify this at the first ggplot call, it's going to apply that to every single geom that comes after. So let's say if we had, if you can think of like a regression where you have a scatter plot, so X, Y, and then you have multiple points and you have a regression line, that regression line would be another geom. And if you have the aesthetics set up at the top level, it would basically show a regression for each level of that level. Sorry, that was super confusing. I don't need to be confusing. Let's just keep it this, like it for now. Yeah, we just specified the aesthetics at the level of the geom and not for the entire plot. But if we wanted to explore this, if this was a more complex data set with more columns and we wanted to show more things, we would just keep adding a plus at the end of the line hitting enter and adding another geom. So geom something. In this case, doesn't make sense because we don't have any more columns that we have not shown yet, but that's how it would work. So the ggplot philosophy is that you start with just the canvas and you start adding components to it line by line. Okay, so let me check my cheat sheet here, see where we are. Perfect. Okay, so the last thing that I want to do here is, all right, so we have this plot, cool. And let's say I wanted to save this to file, so I can include this in a report or a paper or something. How do we get this outside of R and in a format that you can use in a Word file, for example? So there is a function called ggsave, just like that. And then you can open and close quotation marks here. And if you hit tab, it's going to give you a path, basically, like on your computer. So my path right now, I think it's showing where I have this script saved. So I just want to get outside of that folder. So if I hit to get outside of a folder in this type of format, you type .. That takes you a level out. So here I see that I'm probably in that 2022 Advanced PA class folder right now. I will just save that here, just so it's not as complicated for us to be looking for a specific place. But let's just save that here. So let's say to do that, I would basically, and is this what you guys are seeing as well? Are you in that folder? Like if you do.
I'm not seeing that at all. I'm not seeing any pull down menu when I do that. I'm seeing if I've got a typo somewhere.
Okay, so
save, parentheses.
yeah, so you have to have the both parentheses typed
Yeah,
out, and with your
and
cursor in between them, you hit tab.
And tab, yeah.
Okay, must be showing up somewhere where I don't see it. Everybody seeing what Dr. Bastos is showing you?
Christine?
No, Tyson's not. I'm not either.
Huh.
Is it maybe, let's see, does it pop up on a different screen? Let me see.
When I hit tab, when I click inside the quotations, it just pulls up the name of the file.
Okay. I mean, it is, yeah, so it is doing correctly. It's just that wherever that file is, that there only exists that single file in that folder. So it kind of assumes that you're trying to call that file. So Tyson, in your case, just do .. and then hit tab.
Mine says no matches.
Can you say that again?
Mine says no matches. Nothing else, no drop down menu. Even with the ..
Okay, so let's try to do this instead. What happens if you use a tilde and a .. This should bring you to the root of your computer. So you should see folders like desktop, documents, and things like that. If you can try to do that and see. Okay, so if you can see desktop on this drop-down menu, or perhaps you see like a username and then you have to get into that to then get to desktop, let's just try to browse there and let's try to land on our desktop.
I don't think I have a tilde on my keyboard.
Oh, so for.
Oh, yes, I do. Never mind. It's hidden. I found it. Okay. Never used that before.
Yeah, I know. So in Portuguese, we have, so, I'm Brazilian and my native language is Portuguese, and we have that symbol in our in Portuguese language. So I guess I took that for granted and just before mentioning. Were you guys able to find that tilde symbol? Okay.
On the top left of your keyboards, on the US keyboards.
Top left, yeah. For mine is right below escape button or key. So if you're able to get your desktop, so we are in the right place, but now we have to give it a name. So let's just call it like plot1, and then we have to give it an extension, which I sometimes use PNG. I like PNG. So let's just use like that. So desktop plot1 PNG. Now let's just run that. if it worked correctly, you should see this message on your console, saving 4x3" image. And if it didn't work right now, that's okay. I can help you guys later. But the point here is just I wanted to show you can export, and I will actually be showing you next an easier and better way of doing this. We're using RStudio projects. So if it didn't work now, it's all right. It's really important that it works when I show you next time when we do projects. And the point here was to show you, let me show you my desktop. So here's my desktop. That's the plot1.png. If I just double click on that, it is this beautiful plot that we made that, you could add this to a Word file or something. So that was just the goal, to show you that you can actually export it, and things are going to be easier in a moment here. Okay, so right now I think we finished that intro part. I just want to, before we take a quick break, I just want to ask, does anybody have any questions or has had any issues with what we've done up until now? Okay, I don't hear anything, so I'm assuming we're all good. Maybe, George, would you like to stop recording right now, just so we break that into 2 parts?